Welcome to my next lecture. At the first, I request please subscribe my channel and please watch the video online. Usually using the fixed point method, it's very easy, but it is a little tricky because if you want to choose a suitable, in fact, sequence, it's a little tricky and you have to be careful when you want to choose the sequence. Let me state a problem and solve it by using fixed point method. The problem is that using the fixed point method to find a equal to 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over, and it continues in the same way. I want to find the value of a. For this solution, you have to note that if you consider this part of the fraction, this part is in fact equal to a. So you can put instead of all of these terms in fact a. Yeah, so I will get a is equal to 1 over 2 plus a, and it gives 2a plus a squared equal to 1, and this gives a squared plus 2a minus 1 equal to 0. I know that the value of a can be found by the formula that we have for the quadratic equation. Yeah, in fact, I know a is equal to minus 1 plus minus sqrt or square root minus 1 plus 1, and it will be minus 1 plus minus square root of 2. The minus is not acceptable, so a will be square root of 2 minus 1. It's almost equal to 0.41, something like this. Okay, but I want to find this value by fixed point method. So to this end, first of all, we have to define the function f of a equal to a squared plus 2a minus 1. Okay, and I have to find the interval that contains the root. So I test f at 0, it will be minus 1, and also I test f at 1, it will be 3, and this gives, because the multiplication of f of 0 and f of 1 is equal to minus 3 and it's negative, by intermediate value problem it gives that there exists c in interval 0 to 1 such that f of c equal to 0. I want to find c. Now I have to find a sequence from this in fact function, and I have to construct the in fact fixed point sequence. Now we have to construct the fixed point sequence. Okay, We know that there is lots of sequence that I can extract from this equation, a squared plus 2a minus 1 equal to 0. Some of them are acceptable and some of them are not acceptable. For example, if I consider a squared equal to 1 minus 2a and I conclude that a equal to square root 1 minus 2a. I say this is not acceptable because this is not in fact defined for example, a equal to 0.7 under the square root in fact is a negative and I cannot accept this one. Okay, or for example, consider that we compute a, for example, equal to 1 minus 2a over a. Also, this is not acceptable because if, for example, you consider a number less than half, for example, 0.3, so denominator is negative, denominator is positive, and it is negative, and the negative number is not in this interval. So this is not acceptable also. Okay, but one good choice is an plus 1 be equal to half times 1 minus a squared. If you note that all number in the interval 0 to 1 is again in the interval 0 to 1 if I put in this relation. Now choose a0 equal to 0 and we can have this table. Let me write n, for example, equal to 0 and an equal to 0, a0 equal to 0. For a equal to 1, it's enough that you put an equal to 0 here. So an plus 1 is half. So this is half. N equal to 2. You have to put an equal to half. So it's 1 minus 0.21 over 2. And the result will be 0.3750. And we continue in the same manner. For example, for 3, it will be 0.4297. For 4, it will be 0.077. And let me continue here. For 5, for example, it will be 0.4169. And as you can see that it converges to this number that I obtained directly here. Yeah, here. Okay. So we can continue. For example, for 6, it will be 0.4131. For the seventh iteration, it will be 0.4147. In the 8th iteration, it will be 0.4140, and so on. So if you continue in this way, you can finally reach to in fact square root of 2 minus 1, and it will be the in fact the root of the equation. This is a very simple example from using a fixed point method. Please subscribe my channel and follow my channel and wait for the future videos. Thank you.